everyone and welcome back to PostNetwork Academy. In this video, we will dive into an important topic in statistics, independence of origin and scale in Karl Pearson's correlation coefficient. So, the correlation coefficient denoted as R measures of the linear relationship between two variables, and the formula is covariance divided by standard deviations. Now you know that covariance is 1 upon n product of xi minus x bar yi minus y bar, and you will add them all and you will divide it by n. Now you know that the variance of xi minus x bar whole square, you will sum all the deviations from mean and you will divide it by n. In the same way, variance of y. Now here basically we will see that if we subtract a number and if we divide it by any constant, so there will not be any effect or any effect on correlation. In this case we will subtract a from x and divide it by h, and b from y and we will divide it by k, and we will prove that covariance of x y correlation between x and y is equal to correlation between u and v. Let us see that, and that means correlation is independent of change of origin and change of scale. So let us see. So here if we substitute, so we will get xi is equal to ai plus hui and yi b plus kvi, and mean if we calculate, so we will get x bar is equal to a plus hu bar, where x bar is mean of xi's and u bar is mean of ui's. The same way y bar is mean of yi's and v bar is mean of vi's. Now if you subtract, so you will get xi minus x bar is equal to h ui minus u bar. If you subtract y bar from yi, so you will get k into vi minus v bar, and if you substitute these values in covariance, so we will get this one. That means here hk we can take outside and we will have 1 upon n summation from I is equal to 1 to n ui minus u bar into vi minus v bar. So covariance you can say that hk outside and covariance uv. And variance of x, so variance of x you can see that h square variance of u. The same way variance of y k square variance of v. Now the formula of correlation is rxy is equal to covariance xy upon standard deviation of x standard deviation of y, or under root variance of x into variance of y. Now you can say that covariance xy between x and y hk covariance u v, and variance substitute, if you substitute variance of x is equal to h square minus variance of u. The same way variance of y k square variance of v. Let us plug these values. So you can see that correlation between x and y hk into covariance between u and v. Here sometimes I might say correlation is covariance, but where r, so that is correlation. So r xy, that means correlation between x and y is equal to hk covariance between u and v upon h square variance of u into k square variance of v. And finally you will get this one, and rxy is equal to covariance between u and v upon variance of u and variance of v. So rxy is equal to ruv. That means correlation between x and y is equal to correlation between u and v. And that means this proves that the correlation coefficient is independent of changes in origin and scale. And again I will make you remember that change of origin means you are adding or subtracting a constant from each observation, and change of scale means you are dividing or you are multiplying a constant to each observation. So that means if observation is a given and if you subtract a constant from each observation, so there will not any effect on correlation. Or if you divide or if you multiply, there will not be any effect. So the correlation remains unchanged under linear transformations. This property demonstrates independent form, changes in origin, changes in scale. So origin means in our case we have subtracted a from x and v b from y, and changes in scale means we have divided. We could also multiply. So changes in scale means we have divided, and it didn't make any change in correlation. So this makes the correlation coefficient a robust measure of linear association. Now, if you need more resources like quiz, PDF, blog post, you can visit website. For a more playlist, you can visit YouTube channel. On Facebook, you can see videos and a small post related to the topic. LinkedIn page, you can connect to me. You can follow PostNetwork Academy, and you can also watch videos. So hope you understood this concept. See you in the next video. Thank you.